So we're going to talk about function operations with power functions. Okay, so we've already talked about adding and subtracting, multiplying and dividing functions. Now let's do that with functions that that have weird exponents or weird powers. Okay, so to do that, first let's review some of our exponent properties. If I have a to the m, hold on, what is going on? Times a to the n, because their bases are the same, that's the same thing as a to the m plus n.
Totally mishmar.
Okay, now with multiplying a times n, a to the m times a to the n, you added the exponents. So if you have a to the m over a to the n, they have the same base. What are you going to do with those exponents this time? You're going to subtract them. Okay. Now let's say that that subtraction comes out to a negative number. A to the negative m, what do you do with that?
Over 1.
1 over. So it moves to the denominator. A to the m in the denominator. 1 over a to the m.
Oh, yeah.
Okay, so there are a lot of other properties of exponents, but these are the ones that we're mainly going to use today. Okay, here we have f of x is equal to 3x to the 1/2, and g of x is negative 5 times x to the 1/2. So the first example, we're going to add these two functions, f of x and g of x. So that's 3x to the 1/2 plus negative 5x to the 1/2. Now, I can add things together as long as the base and the exponent are the same, right? Because here it says that I have 3 of these things, and I'm going to add negative 5 of the same things. And those things are the x to the 1/2. So how many x to the 1/2 do I have left? I have negative 2x to the 1/2 left.
Is it because you subtracted the 1?
Mm-hmm. Now, I have negative 2x to the 1/2. What's x to the 1/2? That's a square root, right? With the, yeah. So this is negative 2 square roots of x. Alright, so that's if I add them together. Now, I also need to pay attention to the domain. So, now I'm not dividing by an x, so that's fine. But I have to think, this is a square root. There are certain numbers that I can't take square roots of. Right? Okay, you cannot take an even root of a negative number. So since this is the square root, that's an even root. Right? So whatever this x is, it cannot be a negative number and get a real solution, right? So I need to have all the positive numbers and 0. So there's two different ways I could write that. I could write that as all of the x's that are greater than or equal to 0. Another way I could write that is all non-negative x values. So here we have negative 5x to the 1/2 minus 3x to the 1/2. So I have negative 5x to the 1/2, and I'm taking away another 3 of those. It's negative 8 times x to the 1/2. So that's the same thing as negative 8 square roots of x. The square root, right, so it's like there's like a little secret 2 right there. That's an even root. So my domain is anything not negative.
Right, it's the same thing.
So yeah, all of the x's that are greater than or equal to 0.
So that would be the domain.
Yes, that's the domain. Okay, so we have two new functions. F of x is 7x, and g of x is x to the 1/6. So now I'm going to do f of x times g of x. So this is 7x times x to the 1/6. So I want you to think about that first slide that we went over where it was a to the m times a to the n. You just added the exponents, a to the m plus n. Because if the bases are the same, you can add their exponents. So what power is this x being raised to? It's being raised to the first power. So there, even though it says 7x, that's no different than 7 times x. Okay? And that's to the first power, and I can just add in this 1/6 over here. Okay, now to add fractions, I need a common denominator. This is 1/6. How many sixths is in a whole? Like 6/6 makes a whole, right? If this is one piece of the pie, there'd be 6 total pieces in the pie. So we have 7 times x to the 6th over 6 plus 1 over 6. So that's 7x to the 7/6. So to rewrite this in radical form, this is 7 times the 6th root of x to the 7th. Now, look at the root. This is the 6th root, so it's an even root. What does that tell me about the domain? It's got to be greater than or equal to 0 because you can't take even roots of negative numbers. So f of x over g of x, that would be 7x over x to the 1/6. So just like multiplying, these x's, they're the same base of x. This has an exponent of 1, so I can take my 7 times x to the first minus 1/6. So x to the 1 minus 1/6. So 1 is 6/6. Take away one of those, and it's 7x to the 5/6. Rewriting that, that's 7 times the 6th root of x to the 5th. Okay, and then now my domain is the same because it's still an even root. So this is x is greater than or equal to 0. Okay, now the last problem is g of x over f of x. So this is x to the 1/6 over 7x. To make this problem easier on myself, I'm going to break the number away. Okay? So the 7 that's in the denominator, that's the same thing as like 1 over 7 times the things with the x's. So now that's x to the 1/6. Right? Let me make that look a little cleaner. To the 1 over 6 minus 1. Because this is it's being raised to the first power. So whenever we have division, we subtract them.
Why is it minus 1 not plus 1?
So this 1 is, again, the same thing as just 6 over 6. So that's 1/7 times x to the negative 5/6. Now, what do we know about negative exponents? Yeah, they're in the wrong spot. So this is the same thing as 1/7 times 1 over x to the 5/6. Well, that's just 1 over 7 to the 5/6. Or, I'm sorry, 1 over 7x to the 5/6. Or if I wanted to write it in radical form, that'd be 1 over 7 times the 6th root of x to the 5th. Now, here's the thing. I wouldn't have even needed to do all that work if I had already done f of x over g of x. Because, look, f of x over g of x is 7 times the 6th root of x to the 5th. All I did was flip this fraction around, f of x over g of x. Now it's g of x over f of x. And look, this just got flipped. Now, instead of this over 1, it's 1 over 7 times the 6th root of x to the 5th. Okay, now the only difference for this last part is that we still have an even root. So we still can't take square roots of negatives. So we're used to saying, okay, that's the domain is, x is greater than or equal to 0. But this x is in the denominator. And what number can you not divide by? 0. So instead of greater than or equal to 0, this is strictly greater than 0. Okay, so remember that if the x is in the denominator, it cannot be equal to 0. All right, and that's all we'll do.